Hey everyone, CozyAzeroth here. Today we're going to do Chapter 2 of Beginner's Basic for the Texas Instruments TI-99 4A home computer. Beginner's Basic was the basic manual that came with the computer, and it's one of the best introductions to programming you've ever seen, regardless of the computer language. Of course, its basic is different from modern programming languages, but it's an incredible introduction to programming in general. So I did Chapter 1 a while ago, and then I got a little under the weather, and so I'm here to do Chapter 2. So let me get the TI-99 4A emulator, Classic 99 set up. Let's get into TI Basic. Okay, here we are. So we're just going to read through Chapter 2 and do all of the exercises inside the book. So Chapter 2, Simple Programming. In Chapter 1, you used immediate mode statements to instruct the computer to do one thing at a time. Each statement was performed immediately after you pressed the Enter key. You typed print, quote, hi there, and pressed Enter. The computer printed hi there. Now you're ready to discuss programs, sets of statements which are not done immediately. Instead, they are stored in the computer's memory, waiting for you to instruct the computer to perform them. A printing program. Let's begin by using an old familiar friend, the print statement in a program. First, type the word new and press Enter. We don't really need to do that, but since it said to do it, let's do it. That gives us a new instance of TI Basic, clears the memory. New clears the screen, prepares the memories for your program, and lets you know the computer is ready. Now type the following program, pressing Enter at the end of each line. Okay, 10 print, are you ready? 10 print, I always forget about spaces here. Yep, space. Are you ready? 20 print to learn basic, question mark. Okay, 20 print to learn basic. 30 end, and of course this is not a necessary line, and very quickly the programs will move from end, but makes it clear what's going on. You know, you get two print statements, print are you ready, print to learn basic, and then end the program. So for people that are brand new to programming, it makes it clear what's going on. Okay. As you type the program, notice the small prompting character that appears to the left of the printing area. This symbol marks the beginning of each program line you type. In computer terminology, you have just, quote, entered a program. Nothing to it. Check the program now to see if there are any typing mistakes. If there are, just retype the line correctly, including the number at the beginning of the line right there at the bottom of the screen. Then press Enter. The computer will automatically replace the old line with the new correct one. When you're ready to see the program in action, type Call Clear and press Enter. The screen will be cleared, but your program won't be erased. It's stored in the computer's memory. Now type Run and press Enter again. So let's do that. Let's clear the screen, Call Clear, and the program should still be in memory. So we're going to type Run, it will run the program, printing those two lines and ending the program. There we go. I like that the screen color changes to let you know that it's running a program. That's a nice touch. Okay. And this is what we should have seen. And now we see something very much like that. Okay. Want to, quote, run the program again? Type Run again and press Enter. And we should, the screen doesn't get cleared because we didn't add a call clear statement to the program. So we should see the results twice. Run. Yep, and we end up with the same thing repeated twice. Each time you type Run and press Enter, the computer begins at the first statement and follows your instructions in order until it reaches the last statement. End means just what it says. The end. Stop. Did you notice that the display screen briefly turned green while the program was running? The screen always turns green while the program is being executed and then changes back to its normal blue color when the program is finished. Program structure. Now that you've had a bit of programming experience, I love that they call one little program a bit of programming experience. It's friendly, right? You're programming now. I mean, literally, we're programming. Let's review some of the things you did when you entered the program above. To refresh your memory, we'll get the program back on the screen. First, type Call Clear without a line number and press Enter to clear the screen. Now type List and press Enter again. Yeah, so let's clear the screen. Type List, and that will list out all the statements in the program. Okay. List lists what's in memory. Very descriptive. That's one of the nice things about BASIC. The program above consists of 3 statements or lines, quote lines. Each statement begins with a line number, which serves 2 important functions. 1, it tells the computer not to perform the statement immediately, but to store it in memory when you press enter. 2, it establishes the order in which the statements will be done in the program. As in the immediate mode, when you pressed enter when you finish typing each program line. You pressed enter when you finish typing each program line. Pressing enter defines the end of the program line, just as the line number identifies the beginning of the line. It is also the computer's cue to store the line in its memory. Pressing enter at the end of each program line is essential. Without it, your line will not be correctly stored by the computer. And here we have the sample program we typed in. 10 print are you ready, 20 print to learn basic, 30 end. The program performs the program in this order. Also, you may be wondering why we numbered the lines in increments of 10, 20, 30, etc. Well, we could just as easily have numbered them 1, 2, 3. By using increments of 10, however, or other spreads like 100, 200, 300, etc., we can go back and insert new lines if we want to expand the existing program, and we don't have to retype the whole program. We'll cover this clever trick when we discuss editing a program. Okay, commands. New, run, and list. You've already used these commands, but you might like a little more definition of commands in general, and these 3 in particular at this point. Commands are different from statements. They are not part of the program, and they do not have line numbers. Instead, they instruct the computer to do specific tasks. New instructs the computer to erase the program in its memory. It also clears the screen, but don't confuse it with call clear, which only clears the screen. Run instructs the computer to perform or, quote, run the program in its memory. And list instructs the computer to show or, quote, list on the screen the program that is stored in its memory. As you saw earlier, we use new only when we want to prepare the computer for storing a new program. Be careful in using new. When in doubt, use list first so that you can see the current program before you erase it. List is a powerful aid for correcting or changing a program. It lets you get the program right on the screen in front of you where you can check for and correct any errors in your program. And you already know what run will do. It's the magic word that makes it all happen. A numerical program. In addition to its printing or, quote, message capabilities, your computer also has a great deal of, quote, number power. You experimented with addition, subtraction, multiplication, and division in the immediate mode in Chapter 1. Now it's time to try a mathematical problem-solving program. Just to refresh your memory, review the keys that are used to perform the 4 basic mathematical operations. Shift plus for addition, Shift minus for subtraction, Shift asterisk for multiplication, and slash for division. Notice that plus, minus, asterisk are the upper symbols above equal sign, slash, and 8. Yes, of course, so I'm doing a modern keyboard, so I don't have to worry about, on an emulator, so I don't have to worry about the key combinations to produce these mathematical operators. As an example, we can easily construct a program that will convert kilograms to pounds. 1 kilogram equals 2.2 pounds. The first thing we'll do is to clear the display and the computer's memories by typing new and pressing enter. We'll use the variables k for kilograms and p for pounds to help us remember which value is which, and we'll begin our program by assigning values to these variables. Okay, so let's clear the memory, new. All right, so we have a new instance of TI Basic. And let's type the program in here, very small program. 10, let k equals 50, k equal 50. Let k equal 50. Okay. And 20, let p equals 2.2 times k. (2.2 times k). Okay. In this case, we are trying to find out how many pounds are equal to 50 kilograms, so we have defined k as 50. Notice that we have defined p as 2.2 times k. If we stopped here and ran the program at this point, the computer would perform the conversion, but it wouldn't show us the answer. So type in 30, print p. So line 30, all this does is print the value of p. Okay. Now, we have told the computer everything. Have we told the computer everything it needs to do? We've told it the number of kilograms, and we want converted to pounds. We've told it how to make the conversion, and we've told it how to show us the answer. Yes, that's all we need, so type 40 end, which is not necessary, but good for demonstration purposes. your program should look like this. And it does. Before you run the program, let's mention two features of TI Basic that may be slightly different from other versions of the language. First, a prompting character to the left of the printing field on the screen marks the start of every program line that you type. You'll see its function more clearly when you begin to enter program lines that are longer than a single screen line. Second, the end statement in a program is optional in TI Basic. Since it is a conventional part of BASIC, however, we'll use it in this example. Now check the program for typographical errors. If there are any, retype the line correctly, including the line number, and press enter. When you're ready, type run and press enter. Now I know I didn't make any typos, but let's assume I did. So let's retype line 10. Let k equal 50. And let's clear the screen, and let's list out our program. It looks pretty good. Oh, when you're ready, type run and press enter. Let's run the program. Run. 110. So 50 times 2.2 is 110 pounds. And the answer is 110. Your answer is on the screen. 50 kilograms is equal to 110 pounds. Suppose, however, that we want to find the number of pounds that are equivalent to 60 kilograms. Easy. We can do it by changing only one line. Line 10. Now type 10, let k equal 60. Okay, that replaces line 10. Now type run and press enter again. 132. And of course I already cleared the screen, so, oh, I didn't clear the screen. So it looks exactly like what's in the book here. Okay, your first answer, p equals 2.2 times 50, or 110. Your second answer, p equals 2.2 times 60, or 132. Editing the program. What you have just done is called, quote, editing a program. The ability to edit or change a program without retyping the whole thing is one you'll come to value highly as your programming skills grow. And of course now, with modern code editors, you can edit a program as you go long before it's ever run. But it was much more difficult to edit a program back in the day. To give you an idea of the great flexibility editing adds to programming, let's experiment with a few more changes in the present program. Adding program lines. We mentioned earlier that the reason we number program lines in increments of 10 instead of 1, 2, 3, etc. is to allow program lines to be added without retyping the whole program. Before we experiment with a few examples, let's clear the screen and recall our program. Okay, so call clear and list, and that will give us our program back. And we still have 10, let k equal 60. Notice that the prompting character doesn't appear to the left of lines printed by the computer. Only the lines that you typed are marked. We might want to add a call clear statement to the program so that we don't have to keep clearing the screen from the keyboard each time we run the program. Type 5 call clear, then press enter. Okay, that adds line 5 to the program, clears the screen. Now list the program again to see the new line. Type list and press enter. List. And of course, there we go. There's our new line right there. 5 call clear. Okay, the old program is up here, and the new program bottom half of the screen right here. And line 5 is our added line. Compare the two programs on the screen and notice that the computer has automatically placed the new line in its proper order. Run the program again to see the effect of the added line. Okay, run. There we go. It clears the screen first and does the same calculation with k equaling 60. Now let's add another line that will help to point out our answer. Type 27, print, the answer is. Okay, 27, print, the answer is. I think it left a space there, right? Yep. Boom. Actually, maybe not, because it's printing it on a separate line. No, no space. Okay. When you run the program, you'll see this. The answer is 132. Let's do it. The answer is 132. removing program lines. Quite often it's necessary to remove a line or lines from a program. Deleting a program line is a very simple procedure. The program we have stored right now doesn't really have any lines we want to delete. Just for practice, however, let's remove line 5. First, clear the screen and list the program as it is now. Let's do that. All clear. And list. Okay. To remove it, simply type 5 and press enter. Then list the program again. Presto, line 5 is gone. So let's do that. Line 5, that deletes line 5. List the program again, and line 5 is gone. Sayonara. I cleared the screen first, but that's okay. Oh no, I didn't. It looks just like that. Yep. That's all there is to it. To remove a line, type the line number and press enter. The computer will then delete the line from the program memory. Since we really need line 5 in this program, let's re-enter it. Type 5, call clear. Boom. It's important you make the sound effects after you enter a line. Okay, the input statement. You've already seen that you can easily change the value of k by simply retyping line 10 to assign a new value. But suppose you had many values for k and you wanted to find the equivalent value of p for each one. It would get rather tiresome to retype line 10 each time. There is a better way to edit line 10. An input statement causes the computer to type a question mark and stop, waiting for you to type in a value and press enter. The value you enter is then assigned to the variable contained in the input statement. For example, type 10 input k and press enter. Now run the program again. So 10 input k. Okay, run. So we have a question mark. Let's see what it says first. Yeah, it looks just like that, a question mark with a cursor. The question mark and cursor show you that the computer is waiting for you to, quote, input a value for k. This time we'll let k equal 70, so type 70 and press enter. The computer prints your answer. Answer is 154. Looks just like the screen in the book. Now you can run the program as many times as you like, changing the value of k each time the computer prints a question mark and stops. Try the program several times with different values for k. Okay, let's do it. Run. All right, let's just say, what if we have 10 kilograms, 22 pounds. Run. I don't know, 25, 55. Let's just do a couple more. Let's do a really large number, not super large, but 5,678. 12,491.6 pounds. So on and so forth. Oh, hey, it's Kilbro. How you doing? Thanks for joining. We're just doing a little retro programming here today. So we're running through this old basic programming manual, Beginner's Basic, for the Texas Instruments TI-99 4A home computer, my first computer system I had when I was a kid. I did chapter 1 of this book previously, some weeks ago, but then I got sick. And so yeah, just banging through this. So feel free to hang out, enjoy. We're just let me know if you have any questions, by the way. So I'm happy to stop and answer any questions while I do this. If you're familiar with the system, you probably have seen something like this before. If you're not familiar with this, this is the first computer system I had when I was a kid, circa very early 1980s. So let's see. The input statement can also be used to print a prompting message instead of a question mark that helps you remember what value the computer is asking for. Change line 10 again by typing 10 input kilograms question mark, a colon, and then the letter k, the k being the variable that we're interested in. You were born in 94, so yeah, I got a few years on you. I've got, let's see, I was born in 78, so I've got quite a few years on you. Got 18 years on you. 16 years on you. 16 years on you. So you have not seen this system before? The Texas Instruments TI-99 4A home computer. I'm using an emulated version here, of course. But yeah, that's cool. This is how I learned to program back in the day. All right, let's do what it says. 10 input kilograms question mark, colon, and a k. I always have to kind of forget the syntax. It's been a lot of years. Let's see, 10 input. And I forget whether we need Yeah, we need a space. Kilograms? Question mark. Then a colon and K. Hey, my love, just streaming.
Okay.
Working on chapter 2 of this beginner's basic book. So
Perfect.
it's going to take me a while to run through this. I love you.
I love you. Okay, I got some feta.
Perfect.
And then I got 2 bottles of wine. I just got 2 of the ones that we had tried before, like that Firefly one and then the Apothic.
Mm-hmm.
Because they were both on sale.
That's
so
perfect.
I just grabbed those.
Perfect.
And we know we like them, so.
Sounds good.
Okay, I'm going to switch over this laundry.
Okay, I'm just working on this here. It's Killer Bro says she got wine. She trying to get busy tonight.
Oh.
We do the things couples do, you know, to euphemize it a bit. All right, let's do this. So we entered the line. Let's run the program. Kilograms. And what did it say to enter? It doesn't really matter, but let's let K equal 50 this time. Type 50 and press enter. The answer is 110. Looks just like the sample screen. By now your program looks like this. 5 call clear, 10 input kilograms, 20 let P equals 2.2 times K, 27 print the answer is blah blah blah. Okay, yeah, let's list it and make sure it's looking good. List. Yeah, thanks for checking in on me. I was down for the count for quite a few days and I'm feeling quite a bit better now. Feel like myself again here. Okay, program looks very much like the sample program. If you'd like, you can list it on the screen at this time, review the changes you've made so far. When you're ready, we'll go on to look at one more change. String variables. You already know what numeric variables are, numeric values assigned to names or variables like K equals 50. A string variable is a combination of characters, letters and numbers, or other symbols assigned to a name. String variables differ from numeric variables in these ways. The variable name must end with a $sign. The alphanumeric characters in the quote string must be enclosed in quotation marks. Quote strings of numbers cannot have arithmetic operations performed with or upon them. Let's try a couple of examples in the immediate mode before changing the program. Note that this does not interfere with the program stored in memory. Clear the screen, call clear, and enter this. Okay. Call clear. Yeah, I did some Uber driving this week, and I was a little cooked as well. I did about half time this week, which I wanted to make a little more money, but I needed to get my energy back, and now I'm feeling like 98%. Okay, enter this. Let in, I call this in string, in $sign, but I just pronounce it in string. Let in string equal Jack Sprat. Okay, let in string equal quote Jack. I love you. Enjoy your show.
Thank you, my love. Enjoy your stream.
I'll see you in a couple hours. I love you. Jack Sprat. Make sure I got it right here. Yep. Okay. Okay, that stores that value, that string value in the computer's memory, but not part of our program. So now print in string. And we get Jack Sprat. Yeah, thank you. I am too. I wasn't really sick. It just sucked my energy. I had a sore throat and earache, and was just tired all the time. And that was about all that was wrong with me. Really, a lot of fatigue. Okay, now type let W string equal quote what inserting a space 8 no fat. Okay. Okay, let W string equal, and we had a space there, 8 no fat. Right, punctuation mark? Yeah, put a period in there. Proper punctuation. Okay. Okay, now we're going to type print in string, semicolon, and W string. I think that just adds a single. Actually, no, that won't add a space. I think it just prints them right next to each other. We already added the space into the string itself. So print in string, semicolon, W string. Press enter. Jack Sprat, 8 no fat. These references are ancient at this point. They're probably old then. Let's make your conversion program a little more personal by using a string variable. Type these 2 lines. Input name, please. Okay. So 8. Input name, please. Oh, we have a comma there. Name, please. Question mark. And let's see, it's B string. Make sure I got that right. Yep. Okay, and now we're going to add a line 26, print OK space, and then what it's going to do is print B string, so it's going to repeat your name back to you. So print OK space, and then whatever name you enter. 26, print OK, comma, space, I forget which symbol here, semicolon, and B string. I think I got that right. Clear the screen and list the program again so you can see how the new lines fit in. Call clear and list. Well, it's funny you mentioned you're not very smart with the tech stuff. You know, like anything, it's a learning curve, right? You know, one of the reasons I'm smart with the tech stuff is I did this kind of crap when I was a kid, right? So, you know, you do simple things and you do slightly more complicated things and slightly more complicated things, and before you know it, you're better at the tech stuff, right? It's not an all or nothing thing. Okay, when you run the program this time, the 2 input statements will stop the program twice. The computer asks, name please, your name, and then you type in your name and then press enter, and then kilograms, the number of kilograms, and then press enter. Try it. Type run and press enter. Run. Name please, Zachary. Kilograms, 50. The answer is 110. We'll type in alpha, that's a nice name, and press enter. We'll see, name please, alpha, kilogram. Should we do this with the same name, just so it's for parallelism here? Alpha, kilograms. Again, let's type 70 for the number of kilograms. Press enter again, and you'll see, okay, alpha, the answer is 154. So 70. Okay, alpha, the answer is 154. Now let's do it one more time. This time we'll type in CozyAzeroth. Shameless plug. Let's do, I don't know, 57 kilograms. Why not? 125.4 pounds. All right. String variables can save a lot of typing when you're using a message, a name, or a prompting statement, for example, more than once in a program. Now list your program and review these latest changes. We've given you a lot of information, and we've given it pretty quickly. This would be a good time for you to do a little experimenting on your own, trying out some of the things you've learned. Experiment. Okay, want a challenge? Try writing another conversion program, one that converts a temperature in degrees Fahrenheit to degrees Celsius. The conversion formula is degrees C equals 5/9 of degrees F minus 32. Okay. Don't forget to use input statements and call clear at appropriate places. Hint, let C equals, okay, 5/9 to, okay, the parentheses must be there in your program. Well, should we try that? Let's try it. So let's just type new. And it's been a while since I've written a TI basic program totally from scratch, so we'll see how it goes. So let's clear the screen first. Call clear. 20. Let's do the same little name trick. Input name, please. Let's leave a space there. And let's call that name string. Let's give it a more descriptive variable. I like descriptive variable names. Back in the day, they kind of encourage you to use single letters, which are not very descriptive, but I always like descriptive names. Okay, 30. Let's see here. Print. Let's do the same little trick. Nice to meet you. To meet you. Nice to meet you. Okay. Now we wanted semicolon. I think that's what elided the two strings together. Name string. Okay. Now let's do that input statement. So we want to do, we're converting temperature in degrees Fahrenheit to degrees Celsius. Okay, so let's type 40 input degrees Celsius. Or wait, we're starting with Fahrenheit? Yeah, Fahrenheit. Fahrenheit. Question mark. Now let's just call this F string. Okay. Okay, now we want to do some math, right? We want degrees Celsius. Oh, we don't want that to be a string. We want that to be a number. So I made a mistake in line 40. So here's a good example of correcting. We have to retype the line. 40 input degrees Fahrenheit. And we want that to be a numeric string, just F. Okay. Now we want to do some math here. So we want 50, let C equal, and here's our formula here. So 5/9, I'd write them in 9, times, let's see here, F minus 32. Look right? C equals 5/9 of F minus 32. Okay, now let's say 60, print, the answer is, let's get a little creative here. The answer is, we want a colon, no, semicolon. And let's, we want to print the value of C, another semicolon. I think you can do, I think you can do 3 components to a print statement, I think. If not, we'll do it on a separate line, but let's try it and run it and see. It's just been too many years. Degrees Celsius. So print, the answer is, got a little space there, semicolon, value of C, oh, I think I have an extra space here. Yeah, I think I can. Oh no, I left that space on purpose, right? Yep, okay. Degrees Celsius. Okay, that looks good. I think this will do it. Let's run. Name, please. CozyAzeroth. Nice to meet you, CozyAzeroth. Degrees Fahrenheit? I don't know, 100 degrees? The answer is 37.777778, repeating, degrees Celsius. And that totally did the trick. Alright, it's like I learned something since I was 3 years old. I first started writing these basic programs when I was about 3 years old in this environment. The GOTO statement. So far, you've been developing programs that operate from beginning to end in a straight sequential order. There are many situations, however, in which you want it to interrupt this orderly flow of operation. Look at the following program, but don't enter it yet. 10, call clear. 20, input K. 30, print K. 40, print. 50, K equals K plus 1. 60, go to 30. Here we quote, send the program back to line 30 by using a GOTO statement in line 60. The GOTO statement causes the actions performed at lines 30, 40, and 50 to be repeated over and over again, setting up what's called a loop. Notice that we don't use an end statement. That's because the program will never end beyond line 60. It won't stop until you tell it to by pressing clear. This is called a, quote, endless loop. Let's enter the program now. First type new and press enter to erase the computer's memory, and then type these lines, okay? So goodbye to our temperature program, new. 10, call clear. 20, input K. 30, print K. 40, just a blank print line, prints in blank lines. Print. 50, K equals K plus 1. Oops, equals K plus 1. And 60, go to 30. Okay. Before you run the program, we'll examine a diagram called a flowchart explaining how the program works. And here, note that the let is optional. Right? We could say let k equal k plus 1, but we don't need to do that. Okay, so here's the flowchart. 10, call clear, clears the screen. 20, input K, stops and waits for an initial value of K. 30, print K, prints the current value of K. Follow the arrows, we go down. 40, print, prints nothing, just gives you a blank line. Same thing, follow the arrows, go down. 50, K equals K plus 1, reassigns a new value to K, the old value plus 1. 60, go to 30, transfers the program back to line 30, and we follow the arrow, way back up here to line 30. And this is why it's called a loop, because it just repeats in a loop again and again and again and again. Okay. I guess we run the program at some point. Now run the program, putting in 1 for the beginning value of K. Watch how quickly the computer counts. Almost too fast to follow. That's why we added the blank line, line 40. This line spaces out the numbers a bit so that you can see them better. Okay. Let the computer count as long as you want to. When you're ready to stop the program, press clear. You'll see quote asterisk breakpoint at line number on the screen, indicating where the program stopped. Run the program as many times as you want, using whatever number you wish as the initial value for K. Okay, let's do that. And I'm on an emulator. I think I have to get creative. I think it's Alt-4 on my in the emulator, but I think it was Function 4 back in the day to stop a program. Let's run it. Type 1, and here we go, we're counting. Boom, boom, boom. And we can let it run as long as we want. That's long enough, frankly. And we re-broke at line 50. Let's see what it says here. GOTO can be typed as GOTO as a single word in your program. The computer isn't fussy about that. If you try to send the program to a non-existent line number, however, you get an error message. Suppose, for example, actually let's run the program one more time just to drive the point home. So we're going to define an initial value for that variable. Let's just try 500, and it's going to start counting upward from 500. And when we break the program, it's going to tell us what line number we broke at, and in this case it broke at line 40. Okay, suppose for example we type in 60, go to 25, and press enter. Try it, run the program, and see what happens. You'll see this error message. Bad line number in 60. Okay, so 60, go to 20. My habit is to type go to as a single word, but I'm doing exactly what it's telling me to do here. Run the program, and we're going to get an error. Bad line number in 60, as predicted. Right, there is no line 25. We sent it to a line number that doesn't exist. So correct the line by typing and entering 60, go to 30. Okay. Run the program again. Let's start at some random number, 169. So far, so good. It'll just run forever. I mean, until the computer, eventually you get a number large enough the computer can't calculate the number anymore. I forget where this maxes out, but it's quite a large number, so you don't have to worry about that for a while. Let's end the program. And let's see what it suggests we do next. Can we change the program to make it count by 2s or 5s? You bet we can. By making one program change, let's make the computer count by 2s. Type 50, K equals K plus 2. Okay. And press enter. Now run the program, typing in 2, and the computer asks for the starting value of K. we're going to get only even numbers now. Okay. Experiment with the program for a while, making it count by 3s, 5s, 10s, etc. Okay, let's list it out. Oh, let's do something interesting. Let's not just, let's do multiplication. So 50, how about, let's see how long it takes it for it to max out, but how about k equals k times k? How about that? Let's list it out. Okay, so this will be interesting, because if we just type 1, we're just going to get an infinite series of 1s. 1 times 1, 1 times 1, 1 times 1, so on and so forth. But if we enter 2, let's run it again, we're going to get 2, then 4, then 8, then 16, so on and so forth. See the power of compounding very quickly. Yeah, look at that. It only took a few iterations. Let's count how many actually. Run 2, 4, 16. Okay, that went a little too fast. Let me count that again. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 times doing that, the number's too big for the computer. So, okay, let's do something a little different, and then we'll move on in the book here. It's fun to experiment. The book encourages us to experiment, so let's experiment. How about k equals k divided by 10. So let's start with 500. We're getting into small exponents here. I don't know how long this will go on. We'll go on for quite a while, and the computer can handle this kind of operation for a while. Get the idea. A GOTO loop with call sound. GOTO loops have many applications, of course, beyond simple counting. We could use a loop, for example, to practice a musical scale. Before we start the program, you might want to review the call sound section in Chapter 1. See page 17 to help you remember how the call sound statement performs in the immediate mode. It behaves essentially the same way in a program. When you're ready to start the program, type New and press Enter. Our first task in the program will be to assign values to the variables we'll use. Okay, let's real quick, what page are we on? We're on page 39. Let's go up and look at page 17, as suggested. So I got this zoomed in to make it easy to see, but it's a little hard to scroll here. 19, 17, here we go. So yeah, call sound statement has this format. Call sound, we have the duration in milliseconds, the tone in hertz, frequency in hertz, and the loudness level. Okay, piece of cake. Let's go down to page 39. And here we are. Okay, ready to start the new program. So new. Our first task in the program will be to assign values to the variables we'll use. Type these lines. Okay, a bit of typing to do here. Okay, 10, let, is it t equal 300? That's going to be the duration, I believe, in milliseconds. 20, let v equal 2, v for volume. Okay, here we have a C scale here, okay. So 30, C, and these are approximate. Some of these are actually fractional in the real world, so the computer just rounds them, but okay, close enough. You won't be able to hear the difference. 30, C equals 262. This is the frequency in hertz. Okay, 40, D equals 294. 50, E equals 330. 60, F equals 349. 70, G equals 392. 80. A equals 440. A lot of people know that one. A is 440 hertz. Musicians know that. 90. B equals 494. And 100. High C. Notice you can't just call it C, right? We already have a value for C, so we need a way to distinguish high C from regular C, from middle C. So high C equals 523. 523? Yeah. Now you're ready for the call sound statements to tell the computer when to play each note. Okay, let's enter that. Okay, this is going to take a few minutes to type in. 200 call sound TCV. TCV. And basically we're going to repeat the same line going through the scale here. So 300. Yeah, we're going by hundreds here. That's great. Okay, make it easy to see. Call sound TDV. So play the value. Basically play a note with duration T, 300 milliseconds. D would be the frequency for the variable D there, 294, and the same volume level, 2. 400. Call sound T E V. 500. Call sound T F V. 600. Call sound T G V. 700. Call sound. Just a letter there. T A V. 800. Call sound. Keep doing that. T B V. 900. But we have to be careful. Can't just do C again. Call sound has to be a high C. T, high C, and V. That look right? We did it on 900. Looks pretty good. Finally, set up the loop with a go-to statement. 950, go to 200. 950, go to 200. Okay, check the program now for errors and correct any that you find. When everything is correct, run the program. Again, this is an endless loop. Notice that the screen background stays light green until you stop the program. You'll have to press clear to stop it. Okay, let's listen to our scale. Run. Okay, and that would have run indefinitely until we stopped it. We broke at line 300. Okay, experiment. Practice building other musical scales and patterns using the note frequencies listed in Appendix A. I'm not going to bother with that. I do know some music, but it's been a while, and it's just going to take a while to do that, so I'm not going to do that today. But you get the idea. Okay. A go-to loop with call color. Up till now, you've seen only 3 colors in BASIC on your display screen. Maybe you've only noticed 2, but there really are 3. First, while you're entering a program, the screen background is cyan, a light blue color, and the characters, letters, and numbers that you're typing are black. Then, while the program is running, the screen becomes a light green color. When the program stops, the screen returns to cyan with black characters. These are only 3 of the 16 colors available with your computer, and the way you control the colors in a program is through the call color statement. Let's try a program with a call color statement and a slightly different go-to loop. Clear your old program from the computer's memory, type new and press enter, and type these lines. Okay, let's get rid of our music program. Okay, 10 call clear. Oops. Typo. There we go. 20 call color 2, 7, and 12. 2, 7, 12. 30, call HCHAR. That's the command that prints a horizontal string of characters across the screen. Okay, 30, call HCHAR. And 12, 3, 42, and 28. 12, 3, 42, and 28. 40, go to 40. A go-to loop that goes to itself. Now run the program and the screen should look like this. 28 dark red asterisks on a yellow background. The rest of the screen is light green. Okay, run. And that's what we get. Red asterisks on a yellow background on a green screen. So what was fun about this computer back in the day is how easy it was to make cool graphics on the screen. Incredibly easy. Our program prints 28 asterisks across the screen. The asterisks are dark red. In the area where the asterisks are displayed, the screen color is a light yellow. The rest of the screen remains a light green. Line 40 puts your program into a holding pattern that keeps your graphic on the screen. When you're ready to stop the program, press clear to break the loop, which we already did. Remember, you can run the program as many times as you like. Okay, well, let's just drive the point home here. Break, run it again, clears the screen, prints the 28 asterisks on the screen. Okay. A call color statement requires 3 numbers enclosed in parentheses and separated by commas. So for example, 20, call color 2, 7, 12. The first number after the open parenthesis symbol is a character set number. As we mentioned in Chapter 1, each character, letters, numbers, and symbols that prints on the screen has its own numeric code, ranging from 32 through 127, for a total of 96 characters. These characters are organized by the computer into 12 sets with 8 characters in each. And here are the character sets. So for example, just as an example, set number 7, code 80 through 87, the letters P, Q, R, S, T, U, V, W, so on and so forth. Okay. The set number you use in a call color statement then is determined by the character you want to print. And what happens if you want to print characters from different sets in the same colors? We'll discuss that in a few minutes. The second and third numbers in parentheses determine the numbers used in your graphic. Each of the 16 colors has its own numeric code. So we have codes for the symbols, and we have codes for the colors now. Color number 1 is just transparent, so you can have transparent backgrounds. Black, green, light green, dark blue. You know, and I used to have fun experimenting with these different colors when I was a kid. So 2 is black, 3 is medium green, 4 is light green, 5 is dark blue, 6 is light blue, 7 is dark red, 8 is cyan, 9 is medium red, 10 is light red, 11 is dark yellow, 12 is light yellow, 13 is dark green, 14 is magenta, 15 is gray, and 16 is white. The second number sets the foreground color, that is, the color of the character you designate. The third number sets the background color, the color of the block or square in which the character is printed. Okay, so here, for example, 20, call color. We've got 2, 7, 7 would be dark red, the background color is light yellow, and that's 12. The next line in your program is 30, call HCHAR, 12, 3, 42, 28. And I love these little bubbles to explain what these numbers mean. 12 is the row number, 3 is the column number, 42 is the numeric code for the asterisk, and 28 is the number of repetitions. If you need to review the call HCHAR examples in Chapter 1, this would be a good time to do it. Now you know why we indicated set number 2 in our call color statement. The asterisk, code number 42, is a part of set number 2. Line 40 of the program is a go-to statement that goes to itself. It keeps the computer idling until you press clear. When you do, the program stops and the screen changes back to its normal color. All the reds, yellows, and greens disappear. Now let's change line 20 of the program to see some new colors. Stop the program if it's still running and type this. Okay, it is stopped. 20, call color. And now we have 2, 12, 5. 2, 12, 5. And enter that. And let's see what the book says. So the same set number is set number 2, 12 is light yellow, and 5 is dark blue. Press enter to store your new line and list the program. When you're ready, you run the program. You'll see 28 light yellow asterisks against a dark blue background this time. Okay, run. That's what we get. Yellow asterisks on a blue background. Nice. You could, of course, continue to experiment by stopping the program, entering a new line 20, and running the modified program over and over. Don't. Instead, save wear and tear in your fingers by entering the following program, which allows you to experiment more easily. With this program, you enter foreground and background colors in response to input statements. So F would be the foreground color, B would be the background color. So let's type this whole program in. New. Okay, 10 call clear. Input foreground. I like to leave a little space there. We're going to give that the value of the variable name f. 30 input background. We don't need the $sign because these are numeric variables, not string variables. Okay, 40 call color. 2 F and B. Character set 2, foreground color, background color. So if you're still watching It's Kilobro, you can see, you know, there's nothing to this, right? If you start small, it's almost so obvious, so intuitive as to be obvious, right? I mean, there's no such thing as being good with the tech stuff. You know, it's a matter of just practice and practice on simple things until you get good at complicated things. Okay, 50, call HCHAR. So this is the, oops, just deleted there, call HCHAR. This is the command that's going to print a horizontal string of characters across the screen. Okay, 12. So this is the row and column number, row 12, column 3. 42, that's the asterisk. And 28 repetitions. 28 instances of the character. And then 60, go to 60. It's just going to hold it on the screen. Okay, run. Foreground, I don't know, any number between 1 and 16. So let's say white stars on a magenta background. It's funny, I still remember those colors from when I was a kid. There you go. And we can do it again. Run. You want to volunteer some numbers there? It's Kilobro. You still watching? If you're watching, hit me with some numbers, foreground and background. 1 is transparent, remember that. So maybe from 2 to 16, if you're still watching. If not, I'll give you a second. If not, I'll do it myself. I can't imagine this is super entertaining. So, if you're still watching, great. Okay, I don't hear anything, so I'm going to go ahead and get started. Let's do 13. I think that's dark green, and I don't know. How about 11? Dark green stars on a yellow background. There we go. Let's do a couple more combinations. How about foreground? About 9, and maybe a black background. There you go, red stars on a black background. Let's see what the book has to say about this. Okay, here's our little bubbles that explain input color codes for the foreground and background. Set colors based on the input color codes. That's what call color does. And you know what this does, 60 go to 60. Okay, When the computer asks you for the foreground and background colors you want to use, you can type in any color code from 1 through 16. Remember, however, that color number 1 is transparent and color 4 is the screen color when the program is running. These may not be satisfactory in this program. Also, color number 2, black, can cause display distortion on some screens. Here are some combinations you might find interesting. Let's do a couple, why not? I mean, we got time, right? Okay, so we want, let's do 3 and 16. Okay, that's pretty. I think, the goal here is contrast, probably, right? Okay, let's run it again. Next combination, 2 and 11. 2, 11. Nice. Black stars and a yellow background. Let's do 5 and 16. Okay, blue on a white background. Two and 14. Black stars on a magenta background. Seven and 15. There we go, some red stars on a gray background. 7 and 12. Okay. I want to point out something. Notice that the error message we get when we break the program has an asterisk in it. So for a brief moment, you'll see that asterisk change color as well. Right there. Did you see it? Let's run it again. Try it again. We'll do it again. Watch really carefully. That asterisk at the bottom left of the screen change color along with the other asterisks, because we're changing the entire character set which contains that character. For a brief moment before the program ends, that's what happens. Okay, 13 and 12, let's try that. 13, 12, go kind of a different color green on a yellow background. And one more, I think. 14 and 16. Magenta stars and a white background. Okay. Okay, have you checked your program for typographical errors? Have you chosen the foreground and background colors you want to use first? Then run the program. We already did that. After you've experimented with different color combinations, you might enjoy trying some other characters as well. You can do this by retyping line 50, substituting a different character code for the number for the 42, the asterisk code number. Just remember, if you select a character from any set other than 2, you'll also have to change line 40 to reflect the new set number. Okay, so let's find a new character to use instead of the asterisk. Set number 2, why don't we do plus signs, so 43. We'll just change it to 43. Okay. Actually, so let's just use the example from the book, since we're going through the book. So 50 call color, 40 call color. Make sure we get this right. 4, 7, and 12. So set number 4, 7, and 12. And 50, call HCHAR. $12, 3, 61, and 28. Okay, let's run that, because we can ignore the foreground and background colors now. There we go. Gives us a row of equal signs. I'll notice that the equal sign and the question marks are in the same character set, so those all get changed because we changed the color scheme for every character in that character set, set number 4. Okay, earlier we brought up this subject. What happens if you want to print characters from different sets all in the same color? One way to do this is to include in your program 12 call color statements, one for each set of characters. You'll have to do quite a bit of typing, but you'll be free to use any of the characters you choose. Try the following program, which covers 8 character sets. Okay. Okay, let's do that. So let's type new, enter a new program. 100, call clear. 200, I think we're doing by, no, 110, sorry. 110. Okay, so basically call color 1, 6, 16, and then we go all the way through numbers 1 through 8 in the first value there. Okay. Call color 1, 6, 16. Okay, 120. Call color 2, 6, 16. 130. Color 3, 6, 16. 140. Call color 4, 6, 16. 150, call color 5, 6, 16. 60, call color 6, 6, 16. 70, call color 7, 6, 16. 80, call color 8, 6, 16. 90, call color 9, 6, 16. I forget how many of these we needed. Actually, just 1 through 8. So 190 is actually going to be. Let's fix this real quick. Okay. 190 print, and here we can print anything we want. Hello world from CozyAzeroth. Boom. And then 200 go to 200. And that just keeps the message on the screen. So this should change every letter regardless of what character set it's in to the color scheme we chose. Hello world from CozyAzeroth. Cute, huh? Okay. Put a little color in your life. Actually, and use any message you want in line 190. Just remember to enclose it in quotation marks. With these call color statements, you have told the computer to print any of the 64 characters in light blue 6 on a white background. Experiment. Put a little color in your life. Try some experiments of your own with different colors and character sets. For example, what happens into the same color code for foreground and background? Try it. Well, obviously, our text will go away, so that's obvious. You know, we could do. We could try to just make a little, dizzying set of colors here. So let's just do 110 call color. Let's do 1. Let's do 2, 3. 120 call color 2, 3, 4. 130 call color 3, 4, 5. So basically, this is character set 3. Foreground color 4, background color of 5. So we're just going to make a little kind of dizzying multicolor text effect here. Technicolor. 4, 5, 6. 150. Call color 5, 6, 7. 160, call color 678, 170, call color 789, 180, call color 8, 9, 10. Okay, let's run it. There we go. Hello world from CozyAzeroth. Cute, huh? Notice that some of the color schemes are repeated. So like where there are two L's, for example, those are the same color, and L and O are in the same character set. So, and in fact, H is as well. So H and then E is in a different color set. L, L, and O are in the same color sets. That's why those are in the same color scheme. Okay, let's list it out. And let's see what the book says to do next. Error messages. We haven't talked much in this chapter about error messages because for the most part, the ones you'd run into in these program examples are the same as or very similar to those you learned about in Chapter 1. For example, a spelling or typing error in new, run, or list will cause the computer to return a, quote, incorrect statement message as soon as you press enter. Errors in program statements may be detected by the computer either when the line is entered or when the program is run. Here's an example of error conditions and messages you might see when you enter an incorrect line. Condition, omitting a quotation mark, input what color, F but no end quotation around what color. Below are some examples of line errors that would cause error messages when you run a program. So we could try these. Let's just try to generate an error message here. Input what color, question mark, and then let's leave out the quote. We're going to get an error message right off the bat, incorrect state.
Are we postponing dungeon?
Oh, I haven't checked my phone to see if Marina's going to join us later. Let me see. I don't know. You sounds like you'd rather postpone it.
I kind of do.
Okay. If I read between the lines, they are camping.
Okay.
Yeah, let's just postpone it. Or maybe we can play with Julia later. We'll see.
Later, but
Yeah.
past 7.
Yeah, that sounds like a plan.
So I'm gonna wait a little bit longer to get the potatoes to have them soak.
Sounds good. I'm going to finish this up and then I'll be back out.
Okay. While I'm watching.
Okay.
Pictures. I love you.
I love you. Okay, so let's try to generate an error in the program itself. So we'll mistype input here. Input, INPT, what color? And here we'll do our quotation mark correctly. Now if we run that, we're going to get an error, incorrect statement in line number 10. Okay, and we don't need to do the other examples, but for omitting necessary punctuation or typing an incorrect punctuation mark, that should be obvious. That's going to trigger an error message. Leaving the variable out of an input statement, yeah, incorrect statement. But we should do them just to, So 10 input, leaving the variable out, for example, what color. So yeah, no variable. Run. Incorrect statement in 10. Using a non-existent line number. We saw that already, so go to a line number that doesn't exist, so we don't need to do that one. We already saw that previously in the video. Notice that the error message given during a program run usually indicates the number of the troublesome line. If you'd like to view the line in question, let's say line 10, just type list 10. So list 10, let you list a specific line number. And then we can retype it. And input what color. And now we won't get the error message. Now we haven't told it what to do with that color, so it doesn't do anything different. But at least we solved the error message. So breakpoint at 200. You can also list the whole program on the screen if you prefer. Type list and press enter. Remember, too, that failing to press enter at the end of each program line may cause the computer to give you an error message or an incorrect result, depending on the kind of operation you're performing. Making mistakes is a normal part of learning, so don't be disturbed when the computer gives you an error message. Just list the line or the program, identify the error, retype the line correctly, and go right on your way. Note, if you'd like to see all the error messages your computer can give you, or if you don't understand a message you're given, you'll find a complete list of error messages and when they occur in the basic reference section of your user's reference guide, which is the other book. And at some point I want to do videos doing some type-in programs from the user's reference guide. There's some great sample programs, longer form type-in sample programs that I want to do videos for one at a time. So we'll do that in a future video. So summary of Chapter 2. We're at the end of Chapter 2. This chapter, you've covered a lot of very important ground. You've learned how to enter a program, use the commands new, list, and run, quote, edit or change a program, use input statements with numeric variables and string variables, build a mathematical conversion program, create a GOTO loop within a program, stop an endless loop with clear, use a GOTO loop in a call sound program, and use the call color statement in a GOTO loop in a graphics program. When you started working with Chapter 2, you were a beginner in learning BASIC and programming. Now you're well on your way to becoming an experienced computer programmer. Quick review of program structure. 1. Begin each line with an identifying line number, and the line numbers can range from 1 to 32,767. 2. Number the lines in the order you want the computer to follow in performing the program. 3. Press enter when you have finished typing a program line. And that is all of Chapter 2 of Beginner's Basic for the Texas Instruments TI-99 4A home computer system. Let's delete line 10, and let's run our program once more, and we'll end on a high note. Say hello world from CozyAzeroth. And thank you very, very much for watching Chapter 2. There are only 5 chapters in this book, I think, so as the days and weeks move ahead, I will try to find time to blaze through Chapters 3 through 5. It took me a little while this last time. I apologize for that because I was a little under the weather and I had to get healthier before I could do this. But I hope everyone enjoys this look at Chapter 2 of Beginner's Basic for the Texas Instruments TI-99 4A home computer. Thank you so much for tuning in, and have a great rest of your day.